Oh, great, Mark. Come on up, Mark. I want to introduce you. So our next speaker is Mark Griffiths of ARUP, who's going to tell us about the geothermal potential of the Northeast and the UK.
Thank you very much.
Your 2-minute warning. Okay.
Yeah, that's fine. It should be fine. So firstly, thanks for having me. I'm really pleased to be able to talk about a topic I'm passionate about, but it's also great to be in Newcastle as well, which is the birthplace of ARUP. I work for ARUP, so it's really nice to be able to talk here. My name is Mark Griffiths. I'm a principal hydrogeologist at ARUP. I work in our ground engineering team, and I've been at ARUP about 11 years, and I've had the opportunity to work on some on geothermal projects, and I'd like to talk to you today about deep geothermal energy and, as just said, the opportunities for decarbonisation in the Northeast. So just a quick run through the presentation outline. I'll do a bit of an introduction, a bit more introduction about ARUP, then I'll talk a bit about the deep geothermal potential in the UK and the potential for the UK in the future, and then just focusing in a little bit about the potential in the Northeast, and then there'll be time for questions at the end. So ARUP was founded in 1946 by Ove Arup, who was a structural engineer, most famous for his work on the Sydney Opera House, but also, as it was already mentioned before, the Angel of the North was another one of our iconic ARUP projects as well. It's been established in 1946, but developed quite a lot since then, and we're actually involved in all aspects of the built environment. So we have engineers, geotechnical engineers like myself, but mechanical engineers, and offer all aspects of consultancy and design support for built environment. It's an employee-owned firm, which is quite unique, and we're about 17,000 members at the moment, split over 34 countries. And since the 1990s, we've had an increasing role in geothermal projects, all different stages of projects, all different scales and sizes, and all over the world, which has been really good. So now on to the main talk. So I'm sure most of you are aware, and it's been speaking with people over the last couple of days, we're all really aware that there's a desperate need to develop sustainable and low carbon energy in the UK and around the rest of the world for that matter. And the Committee on Climate Change recently reported that heating and hot water make up around 40% of the UK's energy consumption and nearly a third of UK greenhouse gas emissions. So it's really important that we find solutions to this problem, and geothermal should be one of those options, as well as things like wind, as was mentioned before. So what do we mean by geothermal? The term is used quite broadly for different scenarios. I'm talking here about deep geothermal, which the UK government defines as projects that are deeper than 500 metres. But I think it's more important to think about the deep geothermal as projects where the heat is used directly and doesn't need a heat pump to change the temperatures so it's suitable for use in buildings. So I'm talking about the projects on the right-hand side of that image. So considering the UK then and deep geothermal, so a deep geothermal project, like many other commodities, needs a supply and a demand. So on the supply side, you need heat and you need rocks. So you need hot rocks, but the rocks also need to be permeable enough, so they need to have pathways that can allow the hot fluids within those rocks to move around to and from boreholes and take the heat out of that fluid at the surface. And the map on the left-hand side shows a simplified geological map of the UK, showing some different geology types that could be possible locations for deep geothermal projects. There are two types shown. There are igneous rocks, and they're originally hot rocks that maintain some of that heat because they contain radioactive minerals that, radioactive elements in the minerals that, as they decay, create heat. And you've also got deep aquifers. Aquifers are basically water-bearing rocks, and with increasing depth in the UK, temperatures in the world, with increasing depth, temperatures rise. So we're looking at those aquifers that are at sufficient depth where the temperatures are warm enough to be used for geothermal projects. The map on the right-hand side there shows the estimated temperature at about 1 kilometre depth across the UK. And you can see that the temperature range there is between around about 30 and 50 degrees C, depending on where you are in the UK. The average geothermal gradient in the UK is around about 25 to 30 degrees C per kilometre depth. So that does vary locally, and I'll mention that a little bit further for the northeast. So that's the supply side, but you also need the demand as well. So you need a heat user, for example, or an electricity user, but crucially you need somebody who's prepared to pay for accessing that heat. So yeah, but there are various opportunities across the UK for deep geothermal projects. But there are currently very few projects, just a handful, and you can literally count them on one hand. There's a borehole in Southampton, which was drilled in the 1980s, and it was actually a UK government research borehole that was then privatised, and that provides about 20% of the heat to a district heating network in Southampton. And then there are a cluster of boreholes down in, or projects down in Cornwall, the Eden project and the United Downs project, which have recently completed. And Stuart mentioned before that those boreholes were drilled to 5 kilometres depth, of the deepest boreholes in the UK. And they target a granite or a fracture zone within that granite in particular. And they're just going through the commission. Well, the boreholes have been finished. They're going through the testing and commissioning phases at the moment. And there's a project as well in Penzance called Jubilee Pool. It doesn't strictly meet the UK government definition of deep geothermal because it's between 400 and 500 metres depth, but the heat from a borehole, taking water from that site, is used directly to heat a swimming pool, and it's a very sort of popular tourist attraction now. So the question is, why are there only a few projects if there are suitable locations in the UK for deep geothermal? And it comes down to this, the risk profile for geothermal projects. This graph here shows an illustration of basically the risk of project failure throughout the project life and the costs associated along that journey. And you can see that the risk of project failure is very high at the start of the project, and it stays very high until the first borehole is drilled. And to drill that first borehole, because we're talking about significant depths, is actually quite expensive to do. And the dashed line is showing the project costs, and you can see where the drop in the risk happens. You need about 30 to 40% of the project capital costs invested at that point. So you need an investor or some other mechanism to encourage investment, or grants or something like that, to be able to kickstart a few more projects in the UK. And because of that, the Renewable Energy Association contacted ARUP, and they wanted us to help them articulate the possibility in the UK to help them lobby government effectively, so they, to try and encourage a stimulation of a geothermal industry in the UK. The report is available online. There's a QR code at our stand if anyone wants to download the report. Please do that. The main conclusions, though, of the report was that we thought it might be feasible to develop around 15 projects per year in the UK with some kind of government support. And those 15 projects per year, by 2050, that could contribute about 3,500 megawatt heat capacity to the UK, which is roughly the equivalent of about 2 million, heating for 2 million homes. And that in itself, by that point, could contribute 3 million tonnes of carbon saving per year, inject about 3.5 million of capital costs into the economy, and create up to 10,000 or maybe more than 10,000 direct jobs and 25,000 indirect jobs. And importantly, and it was touched upon before, it would allow an opportunity for a skills transition from the oil and gas industry to the geothermal industry. So the oil and gas industry, quite a lot of that work is involved with investigating the subsurface and drilling deep boreholes, which is exactly the same as what you need for a deep geothermal project. So it's actually quite a nice story, and makes quite a convincing case, really, that deep geothermal projects in the UK is a convincing story, good story. So how did we come up with those numbers then, 15 projects per year? So we looked at Europe. So you can see the UK there has 2 projects on there. So the data's a bit old that was used to produce these charts. but there are many more projects in the rest of Europe. Now, you have to be careful about which countries you compare to, because some countries have completely different geothermal characteristics compared to the UK. Turkey, for example, or Italy, the geology is completely different and much more favourable for geothermal projects. But if you look to countries like the Netherlands, for example, have similar geothermal potential, and they have a similar sort of political system to the UK, so that would seem like one of the good countries to compare to. They've got quite ambitious targets, which are supported by government interventions, and they're looking to potentially develop up to 25 projects per year between 2030 and 2050. So even more than what we were suggesting was possible. So how do you incentivise the uptake of geothermal projects? The BGS recently completed a study looking at that and considering those countries I was talking about before, and it's summarised nicely in their report. But the key things are things like risk share schemes, insurances, funding like grants and things like that, and tariffs as well. And we wanted, in our report, to make quite a simple recommendation, because there are so many different options out there to the government, and that was to introduce a tariff specifically for geothermal projects, and we called it a geothermal development incentive. And the reason why we thought that was a good option was because it seemed like a good balance between risk and reward. So the idea behind the tariff would be that only projects that were producing heat would receive the money, so it didn't necessarily risk the taxpayers' money in the upfront and potentially costly investigation phases, but it did make a project more bankable at the early stages, because there was that secure income stream at the end of the project. So then, thinking a little bit about the geothermal in the northeast then. So what do we know? Well, actually it's quite well studied compared to other areas of the UK. There's been lots of good research from Newcastle University and Durham University and other studies as well. And we know that actually the area's got a relatively high geothermal gradient compared to elsewhere in the UK. In places it's 38 degrees C per kilometre, so we talked before about the UK average between 25 and 30 degrees C per kilometre. So that's a good start. We talked about the sedimentary aquifers, and in this region you have an abundance of sedimentary aquifers that are quite deep, so potentially up to 4 kilometres depth. So at that depth, looking at 100 degrees C plus, if you can get the fluid from the ground in those aquifers. There are a number of major fault zones, and these fault zones are often areas of higher permeability, so areas where you can increase the chance where you be able to pull fluids out of the ground, which is the main geological risk associated with these projects. And these major fault zones are the same kind of features that are being targeted in Cornwall by the United Downs and the Eden projects. And you have a large granite pluton, or an igneous body at depth beneath a large area of the northeast as well. That's shown by the hatched black blob, and that's where the Weardale Lithium project actually is located within that granite. And the granites, like I said before, they are originally hot anyway, but then the warmth is maintained by the breakdown of the radioactive elements within the granites. In particular, where the granites are faulted and fractured, that's where you're going to get the permeability for projects. So, where you've got the elevated geothermal gradient, the sedimentary aquifers and the fault zones, you've got an opportunity there for heat projects. And then in the Weardale granite, you might have the opportunity for heat, but also potentially electricity. And lithium, we've already talked about that before. Granites contain minerals that have lithium within them, and therefore the brines in the granites are often elevated in lithium, and that's been proven at the Eastgate site, as Stuart mentioned before. The benefit of the granite, though, is that when looking at the economics, you've got 3 potential revenue streams there from in the Weardale granite. You've got the heat sale, you've got the electricity sale, and you've got the income from sale of lithium as well, which can be extracted at the surface. So it might make a project more favourable when looking at the economics of that. So some conclusions then for the northeast. So I think you've got geothermal characteristics that are good for UK standards. You've got the geothermal gradient, you've got the aquifers there, you've got a granite. So that's a good starting point. I think because of the elevated geothermal gradient, boreholes would need to be shallower than elsewhere in the UK to achieve the target depths. So that means that capital costs for drilling those boreholes are generally lower than they would be elsewhere in the UK. So that helps with the commercial models. You've got various demand for heat in the northeast. You've got the towns, obviously Newcastle, town cities, Newcastle, Durham, and other villages and houses that need heat. You've got hospitals and universities, and you've got the industrial areas that all could use heat and potentially power. The important thing about the power as well is that connecting to the grid. So places like the Eastgate, which it was on one of Stuart's slides earlier, they have actually got a substation there, a direct connection to the grid, so a lot of the costs associated with installing infrastructure to connect to the grid are taken account for at that particular site. But for heat, you need the site to be located nearby to your projects because you can't transport heat long distances. But I think in the northeast as well, you also have this unique situation where you've got an abundance of geoscientists who specialise in looking at deep geology and geophysics and all those kind of things. And you also have contractors. You've got drilling contractors who are experienced in deep drilling and also installing water wells. And it's basically a deep geothermal project is just a deep water well. As Stuart mentioned before, it's a water project, not a mining project for some of this stuff. So it wouldn't be too hard to imagine that in the northeast, with all these things combined, it could be the start of a geothermal industry. You've got all these things here. So, and as this industry would start to take place, you'd start to develop a supply chain, and that supply chain would make things more cost effective over time. And as projects would develop, you'd have greater confidence in deep geothermal because there's more projects to point to. Before, there are only 4 projects at the moment, and some of those are still in their early stages. So with the increase in confidence and the reduction in the costs, and potentially with some government incentives, it could be a bit of a starting point for a deep geothermal industry. So I think it's actually quite exciting for the northeast. So yeah, I think the prospects are good in my opinion. That was all I actually wanted to say. So yeah, just to thank you again to Weardale Lithium for organising this and inviting me to speak. If you want to scan that QR code, you can access our report from that. But otherwise, thank you. Time for questions.
So on to questions. Has anyone got any questions they'd like to ask? We lost the microphone. Any questions from Mark?
Everyone wants an early lunch.
They're astounded. There is one. There's a question. Okay, there we go. Another one there. We've got a couple.
Hi, Simon Hargreaves from Halotech. Have you looked at other sorts of geothermal potential within the UK, for example, from mine water?
Yeah, so we have. I didn't want to touch too much on that because I know that there's going to be a talk on mine water today anyway. But yeah, that's an absolutely fantastic opportunity because what you find with the mines is that they are permeable. They're void spaces effectively, so pulling the water out of the ground, which is one of the key challenges with geothermal, that risk actually is significantly reduced for the coal mines where the voids are just there and the quantities of water are there as well. So yeah, definitely, and in particular in Newcastle, lots of mining. You can see from the room there where the stands are, there's maps of showing where all the coal mines are, so it's another fantastic opportunity. And I should have said that the shallow geothermal is just as important as the deep geothermal in the UK, and will provide loads of opportunity to decarbonise heat.
Oliver Sherratt, Durham County Council. The issue in relation through to risk really sort of like resonates with us very strongly. I mean, we've had a number of projects, not just deep geothermals, but also other schemes where we've needed to really sort of like be bold and test the feasibility. But very often the funders are very sort of like wary of that. And indeed, the biggest decarbonisation fund out at the moment, Salix, is very much sort of like based in relation through to traditional solutions. And I think, and I'd be interested in your views on this, but there is a real sort of like strong role in relation through to lobbying and lobbying sort of like government, in relation through to sort of like unlocking a lot more of the potential that exists there. We as a public body have to be very prudent in relation through to how we utilise our funds, and we can't easily gamble, but there is such a very strong niche in relation through to having a feasibility pot that we could actually access to be able to take some of these bold steps and really sort of like demonstrate that these things can work. I'd be interested in your views. Thanks.
We've been working with some politicians like Kieran Mullen, who is really keen on geothermal. You may have come across him. And we're talking with Bays as well to try and encourage this. And there's various sort of panels where we've got people like Ryan Law, who's responsible for the United Downs project, and we're actually working on a project in Northern Ireland where we're going to be providing some advice on what policies could be used by the Department for Economy there to try and incentivise geothermal projects in a way that balances the risks for everybody. You can almost take it too far one way, where the risk is completely taken away by just throwing grants at that, and that money could be wasted if a project doesn't turn to be successful, and if there's no sort of penalty for that. Yeah, and the tariff side, there's no upfront investment, but you're being paid at the end of the project when you've got the completed project, effectively, which I think could work better because it then encourages better upfront work to make sure that the projects that you do choose, you've got a high confidence in that project. But obviously the geological risk is always going to remain the geological risk, especially when you're talking about boreholes greater than a kilometre. Although the oil and gas industry is obviously very skilled at drilling boreholes to those kind of depths, and the technology is improving all the time. So I think as time goes on, and the oil and gas industry start to think more about what next and how they can make themselves green, I think that's going to become more important, and their inputs into geothermal projects, I think, are particularly important, and that's that kind of skills transition that I was talking about before.
Hey, it seems like the lack of district heat networks is a bottleneck that, I mean, to my mind, district heating is just a no-brainer, and we should pay for it. It kind of reminds me a little bit of what's happening in the water industry, right? No one's really prepared to pay for the leaky pipes because it's old infrastructure and it's expensive to replace. But if you have district heat networks around the country, then you can make combined heat and power plants much more commercially viable. When we bring new nuclear on board, you can just plug that in, and then maybe even further ahead, looking at cold fusion plants, eventually when they come online, we're going to need networks to distribute that heat. How do we get through this, and how do we actually convince people or share the costs or get it in the ground so that projects like this can just get up and running quicker, like they do in other parts of Europe?
It's a very good question. I think it's a hard one to answer, to be honest. So to develop heat networks, you need customers, obviously, and you're basically putting them down one route for heat. And at the moment, there's a choice potentially. You have your gas, but you can choose which supplier. But you would have a heat network that would just be a one source of supply, basically. So you're taking away sort of consumer choice. There are heat networks already in the UK, in Nottingham, for example, and there's one planned actually for the Seaham development, which Charlotte might talk about. That's a new residential scheme where they're using heat from mines, and that would be a district heat network. But yeah, I don't know the answer. I don't know the solution to that, but that's something that obviously needs to be thought about, because these deep geothermal projects are suited for district heating. And I think that's, when I was talking about hospitals and universities, they're projects that are more suitable for district heating networks because they're big estates where a borehole or a couple of boreholes could provide all the heating needs for an estate, rather than having lots of individuals, stakeholders to engage with and sort of sign them up to a heat network. So maybe start with the universities, hospitals, and big industry to get things started, and then move towards residential in the towns.
Okay. Any other questions? Okay.
talked a lot about geothermal, district heating, homes, hospitals, etc. But the other side of it is how much work is being done on recognising that geothermal heat can also be very applicable to food, growing food, agriculture, large-scale greenhouses, and with the added benefit that they can be sited on low organic material, crackland, and that could be done on a much, and cut down food miles and a large scale. I mean, where do you see the application of geothermal going beyond district heating for housing and homes into the agricultural sector?
Yeah, that's another good point, and it's something that we've been thinking about. It's touched on a little bit in the report. Sorry, how do we get that? So it's this supply and demand thing. So you need to have somebody who's willing to pay to get that heat. So the borehole cost could be quite expensive. But one thing we are looking at is old oil and gas boreholes that are now redundant, but the boreholes have been drilled in the past, and there's actually data on the heat available from those boreholes. There's data on the flows of groundwater that you can get from those boreholes, or other ways you could convert those boreholes. And they're often sited in rural areas. So it would make sense to convert those and use the heat from those for these agricultural projects like you're talking about. Be a lot more cost effective to convert a drilled borehole where the risk is lower because you know a lot about them than to drill a brand new borehole that might cost £2 million and not produce the heat that you need.
I think you just hit the nail on the head. It's associated with an integrated scheme, and no, I can't see drilling that expenditure for a borehole purely for geothermal heat, for district heating and farming.
Yeah.
But it could be a byproduct of a wider scheme.
Yeah, no, definitely.
Thank you, Peter. David. Just introduce yourself.
It's David Manning from Newcastle University, and I just wanted to follow up a little bit from Mark's really interesting talk, and to point out that from the point of view of trying to understand more about how geothermal systems work, the government recently invested £30 million in the UK geoenergy observatories. So if you Google UK geoenergy observatories, you'll find out about these. There's one completed in terms of its infrastructure that's in Glasgow that's looking at coal mine geothermal, and that is open for business at the moment and has been generating some interesting results. And ground is being broken on a new facility at the former Shell Research site at Thornton near Chester, which will start construction this next month, in fact. So there has been some investment which will really help to de-risk some of these projects moving forwards. The coal mine-based one in Glasgow, and the one in Chester is based on sandstone aquifers and how those can be used. These are in the public domain as well. So although they're open for anyone to use who wants to, the primary purpose is that the data that are produced by them will be made available to the public through normal channels of the British Geological Survey's data management systems. And I think we'll see quite a lot of the questions which might be following on from your talk, Mark, that would be answered in the fullness of time. The sad thing, of course, is that they don't go down to these great depths, and there we take advantage of the fact, for example, there's a 2-kilometre well in Newcastle where we've got some really, really nice money from Engineering and Physical Sciences Research Council to look at how to get heat from a dry hole, because, of course, that hole turned out to be dry. But we're getting some really interesting results from the way in which that can be engineered to provide heat for a modern building, and so to contribute to networks. So I think there's a lot happening. Really pleased to hear what you've had to say about in their talk today. But I think we're in a rapidly moving situation where I think we just need to have more meetings like this to share that kind of knowledge. So forgive me, that wasn't a question. That was more of a comment. Thank you.
Point. No, thank you.